Hello, Professor. My name is Ariel Maharukin, and I am in your Physics 133 class this semester. The reason I am making this video is to outline my lab setup and essentially show you what this lab is all about and what we are testing. This is lab 1 of the semester, and it's the exciting marble race experiment. So, I have my computer set up here with directions on how to conduct the experiment. And then slightly behind it, I have the ramp, and there's 3 little lines that mark the degree, the steepness that the ramp is gonna fall under. I set it to the lowest one, that's the 10-degree ramp, and I marked 3 places where I'm gonna drop the marble. I started with the steepest incline. And I used some sticky circles to hold the ramp down to make sure it doesn't flap up when we're trying to launch the marbles. And then to measure the length of the table, you see this little monofilament line, and that's attached to a fishing sinker. And oh, I guess that moved a little bit. And I marked where the straight line is with a little sticker. And then that brings us to the carbon paper. You just start out by dropping a marble. And you just drop a marble. It doesn't really matter which one, but you just want to drop it. I started with the first one. I'll pick that up in a second. And then you just watch where it drops. And I just centered where it drops and put my carbon paper there. The reason we put the carbon paper down is so that it makes a little mark wherever the marble drops. And then I just put a little X when I'm done measuring it. I measured it from where the initial drop was with the Fisher sinker. And then I measured it. This is in centimeters, so it would just be point whatever of a meter. I measured it with the measuring tape. And then I recorded it on these tables right here. I mean, I personally like to write all of my tables down. I feel like it makes me remember the information a lot better. And then this was trial 1. That was from the steepest point of the ramp. This was 2. That was the middle incline. And then table 3 was the shortest incline. So table 1, table 2, table 3. And what you'll notice is that the steepest incline was the farthest distance away from the straight drop. And then as you get less of an incline and less of an incline, the distance from the initial drop goes down. This one's in the 0.35, it's almost 0.4 meter. And then the lowest incline was 0.2 meters. That should be essentially our findings of this experiment. The steeper the incline, the farther distance the marble will go from the initial drop point. And then vice versa, the lower the incline, the closer the marble will land to the initial drop point. There's an increase in velocity the higher the incline of the ramp. Oh, and the way you measure the angle of the ramp, you use your lovely protractor and you just measure from the start of the point to where the cardboard lines up on the protractor. I got 10 degrees on this lowest one. And then you just have your marbles. That's what you're gonna use for the drops. And then the microfilament bag. And that's about it. that's our findings. So you start from the highest point and you let it drop. Hopefully that explanation made at least a little bit of sense. You basically just start at the highest line, and then you record that 3 or 4 times, 3 or 4 drops. Go for the middle one. You might need to move the carbon paper, just depending on how far away it drops. You can practice like once or twice. I totally did that. And then 3 or 4 times at the middle one, and then start at the lowest one 3 or 4 times. Mark the average, and that should be your findings. This is my first time taking physics, so please be patient with me. But that should be about it. That's the experiment. Thank you.